Hey guys, in this video I will be building a guitar because this is NCM guitars in custom woodworking, not just custom woodworking. Now admittedly, I haven't built a guitar in a while. So to make it easier on myself, I will be building it out of pallets. Wait. Before we get started, we need to set a few rules for this build. First, no CNC machines, because I don't have one, and honestly, that's no fun to watch anyways. Second, every piece of material for this guitar has to come from these pallets, no outside materials. And third, no epoxy to fill major gaps or voids, because epoxy can absorb vibration and kills tone. So the first thing I needed to do was break down all of these pallets. I tried a few different methods. First, I started with a skill saw, which didn't work very well because the blade kept binding every time I tried to cut more than about ½ inch. I was also doing this in my driveway to keep the mess contained, and bending over like that was absolutely killing my back. Next, I tried using a jigsaw, which was the right tool choice, and I figured putting the pallets up on my sawhorses might help, but it was way too unstable. So then I started thinking, well, what else could I actually use to support these things? And then it hit me. Oh yeah, more pallets. So this ended up being the method I stuck with, and it actually worked pretty well. At that point, I was able to start breaking down pallets pretty quickly. I also didn't really need long boards for this build, so I wasn't too worried about maximizing every single piece of material. I mostly just needed volume, not length. And then I found this really interesting board that I'm planning on using for the fretboard. I honestly have no idea what kind of wood it is. It kind of looks like cedar, but it's really hard, almost like mahogany, but it doesn't look open grain like mahogany. If you happen to know what this wood might be, let me know in the comments. Next, I needed to remove all the nails from the pallet runners. I clamped each piece in my vise and used a hammer and a crowbar to pull them all out. And then I needed to determine the size of the blanks for the guitar, the back, the neck, and the top. But before that, I needed to figure out the shape of the body of the guitar. And I used my Gibson Les Paul as a reference because it has a very standard shape, and I wanted this guitar to fit in a normal Les Paul case without needing something crazy custom. So I started by taking measurements from the guitar. I divided the body down the center and measured the bout, the waist, and the shoulders. Then I drew 3 lines at those points and sketched curves to connect them. From there, it was just a lot of adjusting, erasing, and redrawing until I got the shape I liked. Once I had it right, I cut it out with scissors and used it as a temporary template to make a half template out of hardy board. And originally I started using plywood, but it didn't work out. The process was the same though. Once I had it cut out, I traced the shape out like this and then cut it out on my bandsaw. And if you notice, I'm using the different material here. That's because the plywood was too warped and I needed something a lot flatter. So I just worked my way around the shape on the bandsaw, taking small chunks at a time. Anyways, then using my belt sander, disc sander, and spindle sander, I sanded everything as close to the line as I could get. Then I used a sanding stick to basically blend everything together and try to get it as smooth as possible by feel, and tried very hard not to roll the edges as well. After that, using a piece of acrylic, I scored a center line down the middle and then used that half template and taped it to the acrylic with some carpet tape. Then I tried to cut out as much of the shape as I could with the bandsaw. This was pretty tricky because acrylic is just not a fun material to work with. It melts as you cut it and leaves these massive burrs everywhere. It's also pretty hard on your machines, and I just hate it. So I cut away as much as I could, and then I switched to my router. And I probably could have done this on a router table, but I didn't. Mostly because I don't have one that's easy to set up, and routers already scare me. And a router table, I swear, will be the tool that kills me. Then once that was done, I needed to make a quick template for the fretboard. Nothing serious, just a simple one out of paper. What I'm using here is a guide that you can get from Stu Mac that marks each fret location. I used it to find and mark the 14th fret, which is where the fretboard will meet the body. From there, I cut that out and used it as a reference for where the cutaway needs to be. The cutaway has to end up flush with the fretboard, essentially so I can use that to trace the correct position. Then, using my straight edge, I carefully cut my cutaway sketch out and glued that to a piece of hardboard. From there, the same process again. I cut it out on the bandsaw, then used the sander to bring it flush to the line. After that, more carpet tape to stick it to the acrylic template, and once it was on there, same process again, bandsaw first, then router to finish it off. And quick note, any special tools that I'm using, I'll try to link those in the description, so if I'm using something you've never seen before, it'll probably be down there. And there we go, one guitar template. Now, I did this first because it gives me a way to draw out the shape and keep it as clean and precise as possible, because the next thing I needed to do was draft the entire guitar. This step is really important because everything you do moving forward gets referenced off this draft. If you don't take the time to really map out your guitar, it can cause a lot of problems later on. I know, I've made that mistake before where I kind of just winged it, and yes, it did work in the end, but it always caused problems and opened the door for mistakes. What I used to do was measure a reference guitar, try to remember it, forget, and then end up remeasuring 6 times before I actually cut anything. And I got 2 different guitar necks that will never work for any guitar sitting on top of my cabinet because I didn't have a draft for my guitar first. But anyways, to do this, I basically start by drawing the scale length for the guitar. From there, I can draw the fretboard, then the shape of the body, and everything else gets referenced off of that. Which, the dimensions for the fretboard are ripped off from a Jackson guitar that I have. After that, I draw the headstock, which is actually an original design that I created several years ago and will be reusing for this guitar. To help develop the shape of the guitar, I did use a book as a reference for the design, as well as for the correct locations of everything like the pickups and the saddle. I'll link that book in the description, but you can see it there. But most of the guitars I design are just Frankenstein versions of the parts that I like from other guitars. I also tried to include as much detail as possible, from the pickup cavities and their depth to the mounting brackets and everything else. I was basically using every tool and reference I had available to make sure all the measurements were accurate. Then I went ahead and drew the side profile off camera, which helped me figure out exactly what dimensions I needed for the body blanks. And if I haven't said it already, this is going to be a semi-hollow body guitar. So first, going back to the pallet wood, I tried to clean off as much as I could using a broom because these pallets had a lot of nastiness all over them. Once they were cleaned up, I went through the milling process, joining one side and then bringing everything down to thickness on the planer. I did this in groups of about 20 to 30 boards at a time. After that, I glued about 10 boards together at a time. For this part of the build, I had quite a bit of extra material to work with, so I didn't worry too much about lining everything up perfectly. I basically just stacked them together, knowing I probably had twice as much material as I actually needed. Then I clamped everything down to my workbench to make sure it stayed as straight as possible. Then I just kind of drew a straight line across the top, eyeballing where I could remove the least amount of material but still get a clean edge. From there I went to the bandsaw and tried to cut that line as straight as possible to give myself a little less material to remove on the joiner. After that, I took off the major access on the ends using the crosscut sled. Again, just to remove the amount of material I'd had to remove with the joiner. Once that was done, I jointed one edge to create a perfectly 90-degree angle with the top. And then to get everything nice and square, then I went back and recut the ends and also brought the pieces to their final length. Lastly, I cut everything to its final width using the table saw. Then, using my protractor, I drew a 45-degree line down the center of each board. I used that to help line up each block as I glued them together. I started by gluing 2 boards at a time. If I tried to glue them all together at once, I probably wouldn't have enough clamps and it would have been a lot harder to manage. It takes more time this way, but I get a much better result. Then, anyways, using my track saw, I carefully followed that line straight down the middle, making sure it stayed perfectly 45 degrees with the lamination of each board. Since the track saw couldn't cut all the way through, I then carefully transferred the cut line onto the backside. Then I used the track saw again to cut the entire board in half. Then, using that cut as my reference, I cut all of the triangles off one side. After that, I glued each side together to make one long block. I used 2 cauls on each side to make sure the pieces didn't shift and push past each other, and I also clamped everything down to my bench to keep it straight. Once that was done, I went ahead and ripped the block in half on my table saw. Then I wanted to add 3 stringers down the center. I had this one board here that I used, which I believe is pine, and then I had a thicker board of poplar that I book matched on the bandsaw. After that, I brought each piece down to about 200 thousandths of an inch in thickness and then glued all 5 pieces together. Once everything was squared up, there you go, a neck plate. Moving on to the back, I basically did the same process, only this time I was a little more deliberate about how I glued everything together. I tried to make sure each board was the same size before gluing them together, but I still glued about 10 boards together at a time. After that, I needed to glue these blocks into a square with a 45-degree miter pattern. To do that, I had to take one block from each group of the 3 and cut it in a very specific spot so I could get all 4 corners of the square inside the pattern. Really hard to explain in words, but here's a better example of that, where everything is glued into this kind of weird square shape. The idea was that when I cut out the final square, the laminations would end up running at a 45-degree angle with the edge. That was basically my goal here, at least. It'll make a lot more sense later. Then I cut out the rough shape with the bandsaw. After that, using a flat piece of plywood and some shims, I basically taped the piece down and ran it through my joiner. This way the joiner doesn't push the piece flat as it goes through, but it still gives me a flat surface on the top. Once I get the face flat, I take it off the sled, flip it over, and run it through again, giving me 2 parallel surfaces. Now that was just one square, and I needed to do that basically 4 times, so in the end I had 4 different squares. To glue those together, I needed to make 2 back stripes and to run down the center and perpendicular to each other. For that, I used this runner board that was made out of ash. First I cut the board into a rough square shape, then cut it to length and ripped it in half, giving me 2 thinner boards. And at this point I wasn't really exactly sure what my final plan was going to be, so I definitely made a lot more pieces than I actually needed. But from there, my goal was to bring them down to about 1/8 of an inch thick and remove as many of the nail marks as possible. Originally, my plan was to have 2 boards going this way, one going across this way, and then possibly 2 more going the other direction, like this. But I eventually decided against that because it felt too risky, and I didn't think it would end up looking as good as what I got in the end. So once I had those ready, I took the squares and drew a line that was perfectly 45 degrees to the lamination. Then I taped the piece down to my joiner sled so I could cut that line cleanly. Using that cut as my reference, I squared up one side, trying to match it with the other piece as closely as possible. That way I had a good reference when it came time to glue everything together. From there, I started by gluing 2 pieces together, then finally glued the 2 halves together. While doing that, I kept adjusting the clamps and pressure to make sure everything stayed as flat as possible during the glue up. Then once again, I used the same trick of shimming up the corners so the drum sander wouldn't push the piece flat, but would still give me a flat surface as it went through. I did that on both halves and then glued the 2 halves together like so. By the way, would you just look at how handsome this guy is in his NCM guitar sweatshirt, available at ncmguitars.com? Doesn't it just make you want to support a small business and help it get its face off the floor? If not, well, I guess we can still be friends. Now for the top, this one was definitely going to be made a lot differently than the others. I was really trying to go for like a sun-like shape design. So the first thing I did was draw a line 14 inches long, then sketched a curved line that started and ended at the 2 points of the 14-inch line. After that, I cut the shape out and used it as a template to transfer the design onto a piece of hardboard to make a router template. Next, I cut out a strip of hardboard on the table saw and cut it to length at exactly 14 inches. After that, I traced the curve onto it. From there, I cut out as much as I could with the bandsaw and then sanded as close to the line as possible using the spindle sander. And again, just like with the other templates, I used a sanding stick to smooth everything out, trying not to roll the edges as much as possible. Now once I had this, I needed to make the negative version of this template, which ended up being a lot harder than I expected. As far as applications go, this is probably where a CNC machine would be most ideal. But again, I don't need that. So first I tried routing it out, basically trying to cut the opposite side with the router. That got me close, but it didn't actually work because I didn't consider the width of the router bit acting as a curve. After that, I used chalk to mark all the high spots, and then by hand I painstakingly sanded everything until the 2 shapes matched. Was it perfect? No. Was it good enough? I sure hope so. But if anybody has a better solution to this to achieve this, let me know in the comments. But anyways, I then took another piece of hardboard and using math, I drew a triangle at 20 degrees with 14-inch sides, which would give me 18 sections in a full circle. Using the templates and carefully lining everything up with that triangle, I taped the pieces together and then taped the whole thing to my bench before routing it out. That gave me a perfectly 20-degree triangle, but with curved edges like this. And then for the top, I went ahead and milled and thicknessed all 54 boards in one go, because for this part, I really needed to make sure I paired each board carefully so I could get as much contrast as possible, not just between the layers, but also across the circle. I also tried to avoid putting 2 of the same types of wood right next to each other. My goal was to glue 3 boards together at varied thicknesses so that when I eventually shaped the guitar, it would kind of look like a topography map. And for these, I just glued 3 boards together at a time and then clamped all of them up at once. And I'll be honest, I'm a little surprised I didn't mess this part up because I was definitely rushing due to the sheer number of boards I had to glue. Here I am taking them apart again. Some of them were a little stuck together, but luckily I was able to get them all separated. So the next thing I did was use my template to trace the shape onto each board and then cut them out on the bandsaw. After that, using my best friend, the router table, I carefully routed out each board, trying to follow the direction of the grain. I used one of those 1.5-inch router bits with the bearings on the top and the bottom. That way I could cut one side, flip the piece over, and adjust the router bit height, and continue cutting while still following the grain direction, and not losing any fingies in the process. Then I started by gluing 2 boards together at a time, and my main goal here was to keep everything as flat as possible so each lamination would line up properly. Once I had 2 together, I glued 2 and 2 together to make 4, and then 4 and 4 together to make 8, and after that I had to glue the last 2 single boards onto the halves, giving me 2 halves which made up of 9 boards each. This part was stupid because there wasn't a single parallel surface for me to clamp against, and if I clamped too hard on the curved edges and dented them, it would ruin the glue joints. So once I had the 2 halves together, I cut a line on each one just so I have a flat edge to clamp against. Then using some cawls and my workbench, I clamped everything down just to help keep it as flat as possible while the glue dried. Once it was dry, I used the same process again, putting it on a sled with shims to get a flat surface on the top, then running it through the drum center to give me 2 parallel faces. After that, using the center point and 2 of the boards as a reference, I drew a line perpendicular to them and used that to cut the width of the board, making sure the center stayed perfectly centered. Then I repeated the process to cut it to length. Although for the length, the center didn't actually need to be in the center. Now the next thing I needed to do was inlay a circle into the center. To do that, I used this jig from Stu Mac that's designed for cutting sound holes in acoustic guitars. It's basically just like any router jig for cutting circles, but it's designed to work with a Dremel instead. I used it to cut a 3-inch circle out of a piece of hardy board. Once I had that cut out, I used it as a template to cut the negative circle in another board. Then used those templates to help cut out a circle out of this funky looking board here. I originally tried doing this on the router table, but that wasn't going very well and I do like my fingers, so I taped the piece down to the corner and used a handheld router to finish the job, which honestly is probably the method I should have started with. Then using the circle, I traced out exactly where it needed to go. I did this by drawing a center line down the middle of both the top and the circle, using that line to line everything up, and then basically eyeballing the final position. Once it was where I wanted it, I used some carpet tape to secure the template onto the top, then I carefully routed out the hole. Gluing the insert was pretty straightforward. I just made sure there was plenty of glue and then used my cam clamps to hold everything in place. Once it was dry, I ran the whole piece back through my drum sander and brought it to its final thickness. Alright, that's going to be it for this video. Just a lot to cover, so I'm going to be breaking this apart through multiple videos. In the next video, I plan on addressing some of the gaps that I have and just kind of cleaning that up. And then I also will be adding an inlay on this one. I didn't do that for this video because I need to make my own purfling, which that's going to be a whole process. And then I hope to at least get the body shapes cut out and glued together, and then possibly even get the neck joint done in the next video. So stay tuned. I'll see you in the next one.